Language is, how can I say this? We observe our species as being the only one which masters language. We can produce and understand an infinite amount of sentences, and we are learning it extremely fast. Within a few years, humans and kids in particular acquire language extremely efficiently. They learn to do this rapidly and with an extremely small amount of data. And this requires a skill which at the moment remains unknown. At Meta AI, we are comparing the activations of deep learning algorithms to those activations of the brain. So our efforts today focus on the analysis and curation of large amounts of data. We are making special efforts to curate public datasets and to collect new data. We are teaming up with public partners, including Neurospain at French CEA and INRIA. We work with what we call functional magnetic resonance imaging, and we work with magnetoencephalography. With magnetoencephalography, we can identify at every millisecond the brain responses to individual words and individual sentences. So we can track, as a function of time, the brain responses to words. Comparing human brain responses to algorithms trained to process language. We have areas in the brain which are similar to algorithms trained to do perceptual representations. We have areas in the brain which are similar to algorithms which we call word embeddings, and we have a whole network of brain regions which seems to behave similarly to what we call language transformers.
We found that the better the algorithm is at predicting the next word, the more it resembles brain activity. And this is quite important because it suggests that the internal representations that are shared between brains and algorithms are useful for the algorithm to process language.
But the key question is to try to understand what is different. What makes these algorithms not as good as humans? They are, after all, trained with gigantic amount of data, and yet they remain challenged by some tasks. So given the sequence of word once upon a, the algorithms are trained to predict the word time. But it's not trained to predict something in the long range. It's not trying to predict that a story will unfold. This is something that we believe the human brain is automatically able to do, to anticipate not only the next word, the next sound, but also to try to predict the next ideas.
What we're trying to do is to train this algorithm to predict far-off words in the future and abstract representations of these words.
The end goal for us at Meta AI is to try to both improve our understanding of the brain, but also to try to guide the development of machine learning algorithms in light of our neuroscientific discoveries. We get to study very profound questions. The applications of AIs will change future in many ways, and so that's an exciting landscape to be working on.